At this point, you might be wondering something very important. How do engineers know all these details about a microcontroller? Do they memorize everything? The answer is no. Great engineers do not memorize thousands of facts. Instead, they learn how to find, read, and understand the right information. And their most important source of information is the datasheet. A datasheet is an official document provided by the company that designed the chip. It contains accurate and reliable information about every feature inside the microcontroller. You can think of it as a map and a guide to the entire system. If we look at a typical datasheet, it tells us many different things. It shows the names and functions of every pin. It explains the electrical characteristics, such as voltage limits, current ratings, and power requirements. It describes the features that the chip supports. It provides block diagrams that show how the internal building blocks are connected. And it contains detailed information about registers and configuration settings.
Everything we need is already there. The challenge is learning how to read and use that information effectively. Professional engineers usually follow a simple process. First, they ask the right question. For example, perhaps they want to use the ADC to read a temperature sensor. Next, they find the relevant section of the datasheet. Then, they read carefully, studying the diagrams, tables, notes, and register descriptions. After that, they write code and test their understanding in practice. Finally, they learn from the results, debug problems, and improve their design. This process is far more valuable than memorizing commands, because every microcontroller is different, but the skill of reading datasheets works everywhere. The ability to find information is one of the most important skills of a professional engineer. Throughout this course, we will develop that skill together. We will learn how to open a datasheet, ask the right questions, and build accurate mental models of how a system really works. Remember this important idea. The datasheet is your best friend as an engineer. Learn to read it well, and you can build amazing things with confidence.
Now let us look more closely at what a typical datasheet actually contains. It is the official document provided by the chip manufacturer. It contains everything we need to know to use a microcontroller correctly and safely. At first, a datasheet may look long and complicated, but in reality, it is very well organized. Once we learn how to navigate it, it becomes one of the most valuable tools in an engineer's toolbox. A typical datasheet usually begins with an overview section. This tells us what the chip is and the main features that it provides. Next comes the pinout diagram. This shows every physical pin on the package and explains what each pin can do. Then we have the absolute maximum ratings. These are the limits that we must never exceed, such as voltage, current, and temperature. If we ignore these limits, we may damage the device. The electrical characteristics section tells us how the chip behaves under normal operating conditions. Here we find information about supply voltages, current consumption, timing parameters, and many other important details. The functional description explains how the internal modules work together. This helps us build our mental model of the entire system. Let us look more closely at a pin description. Every pin contains a great deal of information. For example, a pin may have a name such as PA0. It may operate as a normal digital input or output. It may also support several alternate functions, such as an ADC input, a timer channel, or a communication interface. The datasheet also tells us the voltage limits and any special notes we must understand before using that pin. As engineers, we should always check 4 things: the pin name, the pin type, the alternate functions, and the allowed voltage levels. Learning to do this saves countless hours of debugging. A good engineer does not try to memorize everything. Instead, the engineer knows exactly where to find the right information. A simple workflow is usually enough. First, decide what you want the chip to do. Second, find the relevant section in the datasheet. Third, read carefully and take notes. Fourth, apply that knowledge in your code or circuit. Fifth, test and verify your results. And finally, repeat the process and continue learning. This is the real power of a datasheet. It is not just a document. It is a roadmap that guides us from an idea to a working system. Learn to use it well,
and it will become one of your greatest engineering tools.
Now it is time to do what real engineers do. Instead of only talking about datasheets, we are going to open a real one and explore it together. For this example, we will use the STM32F103C8 microcontroller, which is commonly known as the blue pill. Don't worry if you do not understand every detail immediately. The goal is not to memorize everything. The goal is to learn how to navigate the document and find useful information. We will take this journey step by step. First, we will look at the overview page. This tells us what the chip is and what it can do. Next, we will study the pinout diagram and learn the purpose of each pin. Then, we will check the electrical limits so we understand how to use the chip safely. After that, we will explore the main features and internal modules. Finally, we will look at simple application examples that show how these features are used in real projects. Let us begin with the overview page. Immediately, we can learn many important facts. We see that this is a 32-bit ARM Cortex-M3 microcontroller. It can operate at speeds up to 72 MHz.
It contains 64 kilobytes of flash memory and 20 kilobytes of RAM. It supports many communication interfaces, including UART, SPI, I2C, and USB. It also includes timers, analog to digital converters, and a large number of input and output pins. The overview page gives us a quick picture of the entire device. It tells us what kind of problems this microcontroller is designed to solve. When reading a datasheet, there are a few useful habits that every engineer develops. Use the table of contents to find information quickly. Read the headings and summaries before diving into details. Always pay attention to notes, cautions, and electrical limits. And when working with a PDF document, use bookmarks to move efficiently between sections. Remember, this is exactly how professional engineers work. We open the datasheet, we read the important sections, we understand what the chip can do, and then we apply that knowledge in our own projects. The more we practice this skill, the more confident we become. By exploring this datasheet together, we are building something much more important than facts. We are building a strong engineering mental model of a real microcontroller, and that journey starts right here.
By now, I hope you have realized something important. Reading datasheets is not a mysterious skill that only experts possess. It is a skill that anyone can learn. Just like programming, mathematics, or circuit design, it becomes easier with practice. Millions of engineers around the world read datasheets every single day. And now, you are becoming one of them. The most important thing to remember is that you do not need to memorize everything. Instead, focus on understanding the main ideas. Learn where to find information. Take notes and create your own summaries. And most importantly, apply what you learn in real projects. That is how confidence is built. Let us quickly review what we have learned so far. We learned what a datasheet is and why it is important. We explored its major sections. We looked at overview pages, pinout diagrams, electrical limits, functional descriptions, and application examples. We also learned that a datasheet is not just a collection of facts. It is a guide that helps us understand and use a microcontroller correctly. Now we have a simple 5-step method that works for almost any chip.
First, decide what you want the microcontroller to do. Second, find the right information in the datasheet. Third, read carefully and understand the details. Fourth, apply that knowledge in your circuit or your code. And finally, test, verify, and improve your design. Let us think about a simple example. Suppose we want to use pin PA5 as a digital input. We first locate that pin in the pinout diagram. Then we check its description and available functions. Next, we verify the electrical limits and operating voltages. After that, we study the GPIO features, such as pull-up resistors and alternate functions. Finally, we connect it correctly in our circuit and test the result. This is exactly how real engineers work. One small step at a time, one section at a time, one question at a time. Remember, great engineers are not people who know everything. They are people who know how to learn. You now have the roadmap, you have the method, and most importantly, you have the confidence. Continue exploring,
Keep asking questions, keep reading, keep building. Because the future belongs to engineers who never stop learning.
Today, we took a very important step beyond simply blinking an LED. We built a much bigger mental model of how a real microcontroller works. And along the way, we discovered one of the most important tools used by every engineer, the datasheet. Let us quickly review our journey. We started with our old mental movie. Back then, we thought mainly about the LED, a few pins, and some simple code. That model helped us build many useful projects. But today, we zoomed out and saw the bigger picture. We learned that a microcontroller is not just one thing. It is a complete computer system on a chip. We explored the major building blocks inside the device. We met the CPU, the brain that thinks and controls. We learned about flash memory, which permanently stores our programs. We studied RAM, the working space for data and calculations. We discovered registers, the CPU's extremely fast tools. And we met the peripherals, the specialized workers that perform important tasks automatically. We also learned that information must move continuously inside the system. The address bus tells the system where to go. The data bus carries the actual information. And the control bus coordinates everything so that all the parts work together correctly.
When all these pieces are connected, we get a complete mental model of a real microcontroller. Perhaps the most important lesson of all was this: engineers do not memorize everything. Instead, they understand the main ideas and know where to find reliable information. That is why the datasheet is so important. It is the official source of truth. It contains the answers we need if we learn how to read and use it effectively. And now, you know that you can read datasheets too. With a simple method, regular practice, and curiosity, anyone can develop this skill. So take a moment to reflect. What was the biggest new idea you learned today? Which part of the mental model interested you the most? And what would you like to explore next inside a datasheet? Remember where we started. We began with a small mental movie. Today, we built a much larger and more complete picture. And this picture will continue to grow as you learn more. In the next part of our journey, we will go even deeper. We will see how the CPU actually executes instructions and controls everything happening inside the microcontroller. For now, remember these 4 words: understand, explore, build, and innovate. That is the mindset of a true engineer.